Hello everyone, it's A1 Pro, like always, and today we're going to do some keystroke injections with a Raspberry Pi Zero. Now, for those who don't know what Raspberry Pi Zero is, or keystroke injection, or a human interface device, well, let me explain it to you real quick. Alright, so what we're doing right here, we're using a Raspberry Pi Zero, which as far as I'm concerned, it's not really talked about, at least regarding keystroke injections, and obviously I came to find out that you can use it to inject some keystrokes, and therefore you can get reverse shells, or you can do some other beautiful stuff. Now, what we're doing with the Raspberry Pi, we're using it as a human interface device, which is essentially anything that you use to communicate or interface with a computer, i.e. a keyboard, a mouse, a game controller, or whatnot. So what we're gonna do, we're gonna make the Raspberry Pi toward a computer that is a keyboard, and what that's gonna allow us to do is gonna allow us to send keystrokes and basically act as if we were the user using the keyboard. The reason why it's so powerful is because we can do things like bypass their UCA, and we can inject commands that would otherwise take us long to either copy and paste or type in. Alright, so let's get cracking. Now, before we continue, I just want to give some mentions to the following places. So first of all, this tutorial that I found, which is kind of really got me going, it allowed me to set up the Raspberry Pi and all that. So we're gonna follow this tutorial, and everything that we're gonna do today is gonna be in my GitHub, which I'm gonna leave the link in the description below, but you're gonna find this in my GitHub anyways. But this is the tutorial that I found and helped me to set it up. Really simple, just a couple of lines, and yeah, again, it's gonna be everything in my GitHub noted, but I still recommend you to check this website out. Next, honorable mention to Ressa, I'm not gonna mention that, but this guy made a little seven-part series on not just setting the Raspberry Pi Zero as a human interface device, but also developing a script where you can just provide a payload essentially and send the keystrokes. Because this tutorial right here kind of sets you up, but in terms of actually sending keystrokes, you do it in a really manual way, which you don't want. It's gonna take you forever to just send one little payload. So Ressa really made it simpler for me. However, I didn't finish the last two videos, but nevertheless, check it out and show some love. Lastly, Ben, this guy, I love him. His videos are just amazing, and funny enough, I don't know, I just came across this video before I even started all this, which really went into depth about the USB protocol and how it works. And at one point I had to refer back to this video, and it actually helped me out to move forward, because I was stuck, because I didn't know which kind of keystrokes to send at what time. But yeah, definitely check out the video, it really goes into depth and it's really helpful. And lastly, if you are gonna develop, or I guess play around with this, you should check out this PDF that I found, again based on the USB protocol. And if you scroll all the way down here to part 10, I guess chapter 10, I don't know, oh damn, right here it gives you basically the index and decimal and hex values for every character in the keyboard that you can use. Again, Ressa I guess he used it, but I definitely had to refer back and use it for certain characters. Really helpful, definitely check it out. And yeah, so let's go. Alright, now if we go to my GitHub, again links in the description below, okay, you're gonna get to this. So what I'm trying to do, I'm trying to make a framework sort of thing, and right now I just have the keystroke injection module. So when you get the GitHub repository and you clone it, you're gonna get you're gonna get this. So if you go to keystroke injection folder, the readme file gives you basically everything, and we're gonna kind of go through it to set it up. All right, so I'm just gonna put it to the side, and as you can see here, my setup is I have a Raspberry Pi Zero connected via VNC. All right, right here, and then I also have one virtual machine. Don't worry about this one, that's just a server, and I have my Kali box of running the necessary stuff. All right, but again, we're gonna get onto that. So on your Raspberry Pi, this is what we're gonna do. So on the GitHub, we're just gonna clone the repository. So git clone https://github.com/a1pro2003 a1pro_framework. Now I've already done it, but you do that and then download it. Once that's downloaded, we can cd into the folder, and then we can cd to keystrokes. Now in here, if we show what we have again everything, and it has the readme file, which I have right here on the right. So let's read it. Yeah. So keystroke injection, IP and port must be changed for both to change that of the PowerShell script and reverse shell. So again, if you're gonna download this and use it, obviously make sure you change the IP and the port for your own IPs, which again is probably gonna be your attacker's box, which in this case is gonna be my Kali box. Now setup. This is how you set up the Raspberry Pi Zero to act as a keyboard. So all you do is just copy and paste. So when I copy that, enter. I'll copy the next line, copy, enter. When I copy the next line, copy it, enter. So before we move on, let me explain these three little lines right here. These three lines basically just allow this Raspberry Pi to be set up. So it tells the Raspberry Pi to set up and enable the modules that will allow it to communicate as a keyboard. Next couple of lines, let's just copy and paste. So this line creates a file. The next line allows the file to be executed. And the final line is going to allow us to edit the rc.local file. It's going to allow us to edit the rc local, which is going to allow us to add that file that we just created to the startup sequence. So it's going to basically boot up our startup. Once you get into here, you want to scroll down all the way down before the exit 0 line, and you just want to paste in this line right here that you see here. So you subbin and it stick to it, the USB_USB, which you can already see here. I've already pasted it in. And once you do that, Control X to exit, and boom, that's it. All right. Now we want to edit that file that we created. So I'm going to copy the next line and paste it in. Oh. And again, you see here the next page, you just want to copy all that and paste it in. And as you can see, I've already done that. Paste it in. Once it's done, Control X and you exit. And that's it. So that's basically a Raspberry Pi Zero setup. Now, if you encounter any problems when using it in the next following steps, maybe just reboot the Raspberry Pi or try in a different computer, because I had some little troubles as well. But yeah. Also, I have thought to mention the Raspberry Pi Zero. Make sure it has Raspbian installed, because I tried the Jessie version and I had some problems, so I just reflashed Raspbian OS full desktop. And now that we're done, you might be wondering, how do we send the keystrokes? So this is what we do. So I'm just gonna clear everything. All right. Now, obviously you have the repository downloaded, but let's say you wanted to go from scratch. The main bit that you need is essentially this block right here. This what is gonna open up the serial port in the Raspberry Pi and allow it to send the keystrokes. Another thing, the Raspberry Pi, for it to work, you have to make sure that you connect it via the second port, micro USB port. Reason being is because the first one right here is only for power in, so it's only gonna allow, well, give power to the Raspberry Pi. But the second one is gonna not just provide it with power, but also it's gonna allow it to send the keystrokes and communicate with the computer. So yeah, that's the main bit of code. If anything, I have left this file called test.py, which you can use, and it's basically the bare minimum that you need to send keystrokes. But again, you have to do it manually, which is boring, not what we want. Which is why we have this .py keyboard.py file. Which is why we have this keyboard.py file, which handles everything, and all we need to do is create the payloads. Now, I don't want to just move on and not explain it to you guys, so let me explain to you how this keyboard payload works. Once again, it's a combination of Rest's work code and an implementation of mine, but let's go through it. So again, shebang and just import sleep function, because why not? And then I have a try block to import the different payloads. I'm gonna change this, but for now, this is what I got. Yeah, I have to make it neater. But right now, as you can see, well, we're gonna import payload 1, so the first payload. All right. Then this block is what I said before. This is the main block that you need. Again, just handles the serial connection between the Raspberry Pi serial and the computer. Now this next function right here, this chunk right here, came from Ressa, so he made a dictionary with lower and uppercase letters, and what it essentially does, it checks that the key, so the data being sent, or the character I guess, is either in lower or uppercase. If it's in lower, it's gonna send the correct key. Obviously, let's say we send an A, right? It's gonna check, and A, because it's in the lower case, it's gonna send the key for A is 4. It's gonna send 2 no characters, then and 4 character and 5 no characters, in total making 8 bits. Reason being, again, go back and check Ben's video, he explains it, but long story short, keyboard essentially sends 8-bit characters, each representing a number, a letter, a key. So usually the first bit handles any special characters, i.e. control, shift, alt, tab and all that. Then the next character, the next bit is usually 0. Then from the next couple bits, again, handle any other keys, so from A to Z, lower and upper cases. Which is why, as you see here, for any lower case, we send 2 no bytes because there's no special characters, and the second bit is 0. Then the third bit is the one that handles the correct key. And as you can see, if it's in the upper case, it actually sends a character 32, which is essentially just the control key. So if you actually do control and any letter, it's actually gonna give it to you in uppercase, even though cap locks might be off. And that's how you send uppercase. Alright, now this is just something I added just to handle the less than and more than, or left and right arrow, because it was having a bit of trouble. But yeah, as you can see here, at the end of the function, we send 8 no characters. Reason being is because if you only send, for example, an A character like this, if for the Raspberry Pi 0 and the computer, it's gonna feel like you're actually just pressing it down. So therefore, you need to clear that out by sending A no characters, and it's essentially telling the computer that you're not pressing anything else. Cool. Now the next chunk of code, this function right here, basically just handles any special characters or extra commands that you can add, which I did. As you can see here, the first 2, run box and admin press, are my own custom commands, And instead of costume, what I mean is just a combination of keys to do a thing. And what I mean by costume is just a combination of keys. Instead of having to just manually type every key that I want to press, I just have one function that would do a combination of keys at once. So this run box essentially just opens up the Windows run box. So by pressing the Windows key and R, you can see it opens up the run box. Makes it much simpler to use and very effective. Now admin press goes with the run box command. Admin press is what allows you to, once you open the run box and type in your command, you can actually do Control Shift Enter to run that command in administrative mode, just like that. And as you can see, very useful. Alright, then anything after that, the Win key is just pressing the Win key, Control Alt Tab Shift, Control plus Alt, and sleep. The sleep function, another one of mine. So what this does basically, you can input /sleep and a float, so for example 0.5, and what that's gonna do is gonna intake that decimal or float, and it's actually just gonna use it to sleep within the Python code. So just giving you a delay kind of function, so you can delay certain commands and keystrokes. Again, very useful, especially when customizing your own payload. So that's that. And finally, we have the last function, which is basically just handles any special characters, almost like this, but just normal special characters like Control Shift and Tab. It inputs this merge key, which is again just this dictionary of all the keys and special characters, and it checks them and it sends the corresponding one. Again, this right here just adds all these dictionaries into one merge keys, which comes in handy. This sleep 5 is just for testing. I'm just gonna keep it on just for you guys, just in case, but this just allows you time to set up and whatnot. And finally, this for loops right here, what it does, it actually enumerates the data, which is essentially the payload that you're importing. So that payload comes from payloads.payload1, again with the payloads they're gonna make, and that data is split per line. So this first for loop splits the lines, and then the second for loop splits the lines into words. And what it does, it first checks the words count, so it checks how many words in the line, and if that's less than 1, and if the word is merged, then it's just gonna handle it as if it was a normal key. So if it was just control, it's just gonna send control as a normal key. Otherwise, it's gonna translate the line merge key. So what this line is gonna do is gonna check that if the command in the line, if it's not in merge key, then it's gonna execute it as one of the commands that I made. So for example, sleep and winbox. And finally, at the end of every line, we just press enter, because that's the end of every line. And after every loop, we just add some timer. Reason being is because it's just way too fast. If you don't add a little time delay, it's just gonna skip some characters, and obviously you don't want that. I'm gonna have a play around with that, but I don't recommend going lower than this. Reason being again is because it depends on the computer system. So if you do it in a really high-end computer, the keystrokes might register. Otherwise, if you do it in a low-end computer, it might just take too long for the computer to register and miss out characters. And that is essentially the keyboard.py. Now, the payload is actually, if you go back to the Raspberry Pi, you can go to, let's go to a GitHub. You can see here that in payloads folder, we've got payloads. So outside we have the payloads, so payload 1 and payload 2, payload 4, don't worry about that. And then you also have the folders for each payload. So the folder is basically what's necessary for the payload. So for payload 1, which is going to execute first, You can see it only has a PowerShell script, and what this PowerShell script basically does, it essentially, let me show you right here. So what the first payload does, what it does is just opens a RAM box and enters this command right here. And what this command, PowerShell command, does, it just downloads this payload1.PowerShell from my web server and saves that as payload1.ps1. And then finally, it's gonna run it as with admin privileges, left arrow and enter to bypass the UCA box. And when that's done, it's gonna execute the PowerShell. And what that PowerShell does is basically just a reverse shell back to our attacking computer. Now payload number 2, it's a bit different. It does the same thing, so it opens up the box, it sleeps, so I just give it that sleep stroke on 1. Again, depends on the computer system, it might take longer or shorter. Then it's gonna admin press, again, open up the UCA and run it with administrative privileges. Sleep again just to let it load. Then there's different ways to bypass the UCA. Like I said before, you can do left arrow and enter, right? But you can also do alt and then send a Y for yes. And then again sleep just to let it load. And then the PowerShell is gonna run this long command. What this command basically does, it's gonna download 3 different files, which will store the Windows NTLM, which will store the Windows hashes, which will store the Windows password hashes into a file, and also any browser passwords into a file. Then it's going to upload them back into the server, and finally it's going to remove any traces. And yeah, so essentially payload number 1 is a reverse shell payload, and payload number 2 is a password stealer. Alright, so if we go back to our Raspberry Pi, we can actually select what payload. Well, at least now the way to do it, you have to nano keyboard.py, and right here in the first line from payloads.payload1, you can change the number. Right now we want to execute payload number 1. Cool. Now let's go back to GitHub. So in frameworks and keyboards, readme file, we've set it up. All right, cool, nice. One thing I forgot to mention, you can actually make it so that whatever payload you have, in this case keyboard.py, which is the main Python script, we can actually make it so it runs as startup. The reason we want to do that, or the reason you might want to do that, is because if you want to use it in a victim computer, all you want to do is just plug it in and let it run, and then disconnect and skedoodle, right? You don't want to plug it in, SSH into it, run the script, wait for it to finish, and then gone. No, you just want to plug it in and go. So to do that, just like we did before, we're going to edit the RC local. So you copy this folder, this command right here, and whatever the keyboard.py script is, you just want to put that directory right at the bottom, again right before exit.0. In this case, as you can see here, I have /home/pi/keyboard.py. I'm just gonna comment that out because I don't want that right now. But yeah, that's a good way to have it as startup. Cool. Now if we move on, useful links, we've already run through that, and payload number 1. So let's go through this quickly. So first main payload, reverse shell payload. The attacker must have a file server with the PowerShell located in it with the IP and port pointing to the listening attacker computer, probably itself. Simplest and fastest way to do start Python server with this command. So what that means by that, if we go back to our Kali box, which is the attacker, and we log in, you can see here that I have obviously my reverse shell listening, netcat listening, and my server already listening, and my server already working. But as you can see here, I'm in a directory in my desktop called server. Now in server, like it says in my GitHub, you should have a payload.1.ps1. Now don't worry about the rest of the files. These are for payload number 2. I just keep it in the same one. But once again, this is already set up in the GitHub. If you go to payloads, payload number 1, you can see this is what you're gonna put in the server. And if we go to payload.1, you can see this command right here. Now you want to change these 2 IPs right here and the port. Now you just want to change these 2 IPs right here and the port to your attacker's machine. And yeah, that's what I have right here. Now it says here, to start the server you can use Python or PHP. Now for payload number 1 you can use Python, doesn't matter. But for payload number 2 you need to use PHP. But just to keep it simple, we're going to use PHP for both. So PHP dash uppercase S 0000 colon 8000. That's my port. And as you can see right here, it's already working. Now this request that are coming in is just from my server. Don't worry about it. It's just checking if my server is alive. Then you have to ensure that the port is the same in the payload. Alright, we've done that. The reverse shell can easily be started with a netcat with this command. So as you can see right here, I got my netcat listening nc/-lvp 4040. That's gonna open up any netcat listener on port 4040. And that should be the setup. Assuming you've done everything correct and the Raspberry Pi is set up and the attacker machine is set up, we can actually run a script. So let's run it. Now to do that, we're just gonna give our script execution rights. So that's gonna allow us to execute the keyboard.py script. And finally, we just wanna run it with ./keyboard. I'm gonna select my Windows machine. Hands up. As you can see, it was done. That's it. 5 seconds, most. So as what you saw right there, the RAM box was executed. The commands were launched. Control-Shift-Enter was pressed. Well, it doesn't work. PowerShell. Control-Shift-Enter. The UAC box. They pressed a left arrow and enter. And then wrote the whole script right there, PowerShell, as you see executed. Now what did that do? Well, let's check it out. Alright, so if we go back to our Kali box, you can see right here in the server, you can see that payload.ps1 was downloaded right here, which means the payload was downloaded. Good. As you can see right here in a netcat listener, got a connect to 192.168.1.166. Mad. That means that if we do who am I agent/pc/agent Windows System 32. Do you know what that means? We are in System 32, which means we have admin privileges. So we can do whatever we want right now. Start CMD. Obviously, who wants to do that? No one. But it's an example. Alright. Now we have completely taken over the computer. We have a reverse shell, which we can escalate to a interpreter shell, which I'm just going to do that in the future in another video. But it doesn't get better than this. Okay, doesn't work. IP config. It doesn't get better than here. Now that's payload number 1. Beautiful. Reverse shell and administrative privileges. Couldn't get better than that. Alright. Now let's check payload number 2. Alright, so for payload number 2, again we just need our server. So let's go back to your GitHub and read through payload number 2. So for the second payload, password stealer payload, it was still NTLM hashes, password hashes, to be cracked. So the Windows passwords will be retrieved as hashes, which need to be cracked. But and then browser passwords, plain passwords, which you can easily use straight away. For the main recovery of the password hashes, a PHP server must be deployed with a file to handle the upload of the files containing the password. So again, we just need the PHP server with the necessary files in the root directory. Once again, everything is in server folder in payloads folder. So if we go up here to payloads and payload 2, then /server, you have mimicat 64, mimicat 32, and upload.php and webpass. Alright, so upload.php contains this piece of code which just handles any uploads, and webpass handles the web passwords, so the browser passwords, and mimicat 64 and 32 is what is going to retrieve us those hashes. Now, for copyright reasons or whatnot, I'm not going to include them, but it's up to you to download them and put them inside for them to work. So we go down here, we set up the PHP with this commands right here. Now we set up the PHP file with this piece of code right here. Once again, it's already set up for you, but if you want to do it manually, then there you go. And we start the server like we did before. Now just to show you again, ls list, you can see I already have the necessary files right here. Alright, so I'm just going to start the server once again, and we can leave it there running. Now once again, if we go back to our Raspberry Pi and we change the payload, so we will need to nano keyboard.py, and we need to change the import so to payload 2, and then just exit and save it. Now again, we want a nano keyboard.py, and in the import we need to select payload number 2. As you see, I already selected it. Control exit, so Control X to exit, and we just run the keyboard payload. Enter, and then select Windows machine and hands up. As you can see, run box is opened up, PowerShell executed with admin privileges, UAC bypassed, PowerShell opened, code implemented, waiting for the upload, blah blah blah, only takes a couple seconds, uploads, downloads, removes files, boom, exit. That's it, couple of seconds. And now we go back to a machine, attacking machine, so Kali box. Whoop. You can see here we have a lot of files being downloaded. So we have the 3 files being downloaded, and then a push request, 3 push requests for the 3 different files being uploaded. Now, if we check our folder right here, server folder, you can see we have 3 files right here, dated and with the time. And if we open them up, let's open the first one. This one is gonna be mimikatz, but this one didn't work, and that's why we have both versions 64 and 32 for both machines, because you could do a neo way, but I couldn't be asked. But I'll definitely work on it in the future. The next one probably does work, the mimikatz, and this has all my passwords. So I'm just gonna not scroll through that, but there you go. That's the NTLM hashes for the Windows machine. And lastly, that's gonna be the Wi-Fi passwords. Once again, it has all my passwords. I'm not gonna scroll too much, but it has every password, username, and the URL. It's just beautiful. Now with that guys, is everything. Please, this is just for educational purposes only. Be careful with what you do. Alright, I'm gonna leave the description to everything down in the description below, but I do not condone any malicious behavior, so please be careful with what you do and just learn. Please share it. Alright, get the word across, let people know how to protect themselves, because all it takes is for you to make sure that you know where you're connecting to your computer, and for you to have total awareness over your computer. Don't leave your computer unattended, even if it's for 10 seconds. You can see it only takes several seconds to get a reverse shell or to steal all your passwords, and you definitely do not want that. Alright, so please share this information, family, friends, to make sure they know how to protect themselves. But nevertheless, have fun and keep on hacking.